Now here we are going to discuss about a Gauss forward central interpolation formula. So in a previous lecture we discussed about what is the notation of a central difference operator, what is the relationship between central and shift, central and forward difference operator, and how we construct the central difference table, and how we write the central difference table in terms of a forward difference table, and which type of values we are going to use for central forward interpolation formula, central backward interpolation formula, or Stirling formula, or Laplace-Everts formula, or Gauss-Bessel's interpolation formula. So here what is the meaning of this one? First we write a Newton forward interpolation formula, then we try to express the Newton forward interpolation formula in terms of values of a central line and next to the central line. So what is the Newton forward interpolation formula? As we say that there are two ways, means we assume that there is a polynomial of a degree n satisfying the data x0, x1 up to xn, y0, y1 up to yn, and we calculate the values of a0, a1, a2 up to an in terms of a central difference operator. So this way to derive the Gauss forward interpolation formula is much easier in comparison of or you may say also less time consuming. Okay. So here we are going to derive the Gauss forward interpolation formula using the Newton forward interpolation formula. So what is the Newton forward interpolation formula? Here we write what? Using Newton's forward interpolation formula. Forward interpolation formula using forward interpolation formula. So what is the forward interpolation formula? Now Newton forward interpolation formula. Newton forward interpolation formula is what? Y equal y0, you have fx equal y0 plus u del y0 plus u minus 1 upon factorial 2 del 2y0 plus u minus 1 u minus 2 upon factorial 3 del 3y0, and similarly what is the last term? u minus 1 u minus 2 up to u minus n minus 1 upon factorial n del n y0, for what? For the pair of values what? x0, y0, for y0, x1, y1 up to what? xn, yn, where u is a what? U equal, if we write what? Where u equal x minus x0 upon h, So in order to derive the Gauss forward interpolation formula, as we discussed earlier, we use what? We use the values of a y0, then del y0. In a 0th order forward difference, we use the value of a y0. In a first order forward difference, we use the del y0. In a second order forward difference, we use the del 2y minus 1. In a third order, we use the del 3y minus 1, then del 4y minus 2. So how we write here means this one is okay, there is a no change, there is a no need to change in here, means a y0, because there is a need to write y0 then in term of a del y0, in term of a del y0. So there is a no need to change in a first and second term. There is a no need to change in a first and second term, because first term is expressed in term of a what? In term of a y0, and second term also expressed in term of a delta y0. So what is the difference between a Gauss forward and Newton forward? In a Gauss forward, we started from the x0, x1, x2, x3, x4, but in a Gauss forward, we assume that central value with the x0, middle value with the x0, and next central value with the second order. Here we are going to use the del 2 y minus 1, del 2 y minus 1, del 2 y minus 1. So here there is a need to write this term in term of a y minus 1. So how we write del 2 y0 in term of a del 2 y minus 1. So here we use what? Del 2 y0, we may write here del 2 y0 as a what? Del 2 what? E of y minus 1, y minus 1. Because if we operate the shift operator on a y minus 1, then this become what? Next value. Next value is a what? Y minus 1, next value is a y0. So E of a y minus 1 become what? E of a y minus 1 become y0. So this one equal del 2, the value of a E equal what? Equal, as we know that delta equal E minus 1, so E equal 1 plus delta, 1 plus delta, E equal 1 plus delta y minus 1. So this become del plus del cube y minus 1. So this become what? This become del 2 y minus 1 plus del 3 y minus 1. Del 2 y minus 1 plus del 3 y minus 1, because we know that del equal E minus 1 and E equal 1 plus deltas. So this one is using the relation between, here we use two operator, means first we use the shift operator, then we use the relation between shift operator and forward difference operator. So now we able to write in place of a del 2 y0, we able to write this one, means in place of a del 2 y0 we may write what? Del 2 y minus 1 plus del 3 y minus 1. Similarly, del 3 y0 can be written as del 3 y minus 1 plus del 4 y minus 1. Similarly, all other term we may able to express del n y0 with the del n y minus 1 plus del n plus 1 y minus 1, del n plus 1 y minus 1 become 0. So if we simplify this one, then what is the, after putting the values here, del 2 y0, the Newton forward interpolation formula become what? Newton forward interpolation formula become y equal y0 plus u del y0 plus u minus 1 upon factorial 2, and this become what? Here we write del 2 y minus 1 plus del 3 y minus 1 plus, if we write one another term, so this become what? plus u minus 1, u minus 2 upon factorial 3, and this become what? This become, here we write a del 3 y minus 1 plus del 4 y minus 1 and so on. Not infinite number of a term, nth term, u minus 1, u minus 2 up to u minus n minus 1 upon factorial n, or here we write a what? Here we write a del n y minus 1 and so on. So, after that there is a need to write the values of a del 3 y minus 1, del 3 y minus 1. So, we have a value of a del 3 y minus 1. So, there is a need to convert del 4 y minus 1 in term of a y minus 2. Again we repeat this procedure in order to convert the del 4 y minus 2 into a del 4 y minus 1 into a del 4 y minus 2. After repeating procedure of this one, after repeating the above procedure, we may able to find out a what? We may able to find out a Newton forward interpolation formula. What is the Newton forward interpolation formula? Here we write a Newton forward, not a Newton forward interpolation formula, Gauss forward central interpolation formula. So, what will happen here? y0 equal y0 plus u del y0 plus u minus 1 upon factorial 2 del 2 y minus 1 plus u plus 1 u minus 1 upon factorial 3 del 3 y minus 1 plus u plus 1 u minus 1 u minus 2 upon factorial 4 del 4 y minus 2 and so on. So, how we remember? There is a one trick to remember this Gauss central interpolation formula. There is a u, then after that there is a increment in a factor u minus 1, then there is an increment in a previous factor of a u plus 1. The next value is a u minus 2, the next value is a u plus 2. So, in this way we able to remember the Gauss forward central interpolation formula very easily. So, similarly, in a similar manner we also able to write what? We also able to write as well as we able to derive the Gauss backward central interpolation formula. So, here I am not going to derive the Gauss backward central interpolation formula, because you may able to derive in a similar manner. You may also say this one is treated as an exercise how we derive the Gauss backward central interpolation formula similar manner, similar to the Gauss forward central interpolation formula. So, just here I am going to write a what? I am going to write a Gauss backward central interpolation formula. But in a Gauss backward central interpolation formula, in a first order we use the y0, in a second order, in a zeroth order we use the y0, in a first order we use the del y minus 1, in a second order we use the del 2 y minus 1, in a third order we use the del 3 y minus 2, and in a fourth order we use the del 4 y minus 2. And if we find the average of a Gauss forward and Gauss backward, then be able to write a what? We able to write a Stirling central interpolation formula. So, now we are going to write these three interpolation formula directly. So, in the next phase we are going to write a Gauss forward, Gauss backward and central interpolation formula. First we write a Gauss forward, Gauss's forward, central interpolation formula. Interpolation formula. Central interpolation formula. So what is the Gauss forward central interpolation formula? We write y equal fx equal y0 plus u minus 1, sorry, not a u minus 1, here we write a u del y0 plus u minus 1 upon factorial 2 del 2 y minus 1 plus u plus 1 u minus 1 upon factorial 3 del 3 y minus 1. Again we write a one term again, so this become plus u plus 1 u minus 1 u minus 2 upon factorial 4 del 4 y minus 2 and so on. In this way, this one is a what? Gauss forward central interpolation formula. Similarly, we write a Gauss backward central interpolation formula. Gauss's backward central interpolation formula. Central interpolation formula. Central interpolation formula. So what is the Gauss backward central interpolation formula? In a similar manner, we write a y equal fx equal y0 plus what? Gauss backward central interpolation formula, this become u del y minus 1, because there is a need what? There is a need to write a backward interpolation formula in term of y0 and del y minus 1, del 2 y minus 1, del 3 y minus 2, del 4 y minus 2. So here we write u del y minus 1 plus u plus 1 into u upon factorial 2 del 2 y minus 1 plus u plus 1 u minus 1 upon factorial 3 del 3 y minus 2, and if we write one another term, so this become plus u plus 1, so this become what? U plus 1 u plus 2 u plus 1 u minus 1 upon factorial 4 del 4 y minus 2, del 4 y minus 2. So and what is the value of a u? Obviously the value of a u is a what? For both values here u equal, where u equal x minus x0 upon h, and here also u equal x minus x0 upon h, x minus x0 upon h. So this one is a Gauss forward and this one is a Gauss backward central interpolation formula. If you find the average of these two, then be able to find out a Stirling central interpolation formula.